Hi all, today I gonna introduce to y'all simple harmonic motion. In this chapter, one type of vibrational motion, that is simple harmonic motion, will be discussed. What is meant by simple harmonic motion? It is a periodic motion about a fixed point without energy loss. What is meant by periodic motion? The back and forth motion of an object about a fixed point. Hi all, I'm gonna show you the oscillation of a simple pendulum. This is the position of the pendulum when in equilibrium. The tension in the string balances the weight of the bob. The maximum distance from the equilibrium position is known as the amplitude. The period of oscillation is the time taken for complete oscillation. The frequency is the number of complete oscillations per second. Define simple harmonic motion. It is a periodic motion without loss of energy, which the acceleration directly proportional to its displacement from the equilibrium position, and it is directed towards the equilibrium position but in opposite direction. Or we can use the formula of A equals to negative omega square times x. A is the acceleration of the body, omega angular velocity or angular frequency, and x is displacement from the equilibrium position. What is meant by negative sign? In this formula, negative sign means that the direction of acceleration is always in the opposite direction to the displacement x, and it is always directed to a fixed point. In this section, we're going to see kinematics of simple harmonic motion for displacement of the particle. X is displacement, t is time. Displacement in meter, time in second. At time t equals to 0, displacement x equals to 0. Graph shows the displacement x of the particle after a time t given by x equals to a sine omega t. X is displacement, a is amplitude, omega is the angular frequency or angular velocity, t is the time taken of the particle. You will get a beautiful sinusoidal graph. If the particle starts from the positive a amplitude, at this point t equals to 0, x equals to positive a. So the graph shows the displacement x of the particle after a time t given by x equals to a cos omega t, or x equals to a sine in bracket omega t plus pi over 2. When you expand this mathematically using the concept of trigonometric, x equals to a sine omega t cos pi over 2 which is equals to 0 plus a sin pi over 2 which is equals to 1 cos omega t. So cos pi over 2 becomes 0, sin pi over 2 become 1. It is become sin 90 equals to 1, cos 90 equals to 0. So x equals to 0 plus a cos omega t. So the answer is x equals to a cos omega t, which is similar to this. And finally, when a particle starts at time t equals to 0 and x equals to negative a, the graph shows the displacement x of the particle after time t given by x equals to negative a cos omega t, or x equals to a sin in bracket omega t minus pi over 2. When we expand these equations mathematically by using the concept of trigonometry, x equals to a sin omega t cos pi over 2 which is equals to 0 minus a sin pi over 2 which is equals to 1 cos omega t. This is cos 90 equals to 0. This is sin 90 equals to 1. So x equals to 0 minus a cos omega t. And the answer is x equals to a negative a cos omega t. Similar to this. Simple like a bubble without giving you any trouble. We go through again all the graph. For velocity of the particle, when the particle at the point of equilibrium, x equals to a sin omega t. Take it as equation 1. When we differentiate x into t, dx over dt equals to velocity, you will get v equals to omega a cos omega t. Take it as equation 2. To get the clear view for this mathematical method, we have to understand calculus. This is the examples. Differentiate sin x, you will get cos x. Differentiate cos x, you will get negative sin x. When you differentiate sin 2x, you will get 2 cos 2x. When you differentiate cos 2x, you will get negative 2 sin 2x. I applied this method to form this equation. By using one of the trigonometric identities, which is sin squared theta plus cos squared theta equals to 1, theta equals to omega t. So now the equation is sin square omega t plus cos square omega t equals to 1. Take it as equation 3. From equation 1, sin omega t equals to x over a. From equation 2, cos omega t equals to v over omega times a. We can substitute these two equations into equation 3. Then mathematically you can solve the problem and you can derive the velocity of the particle, which is v equals to positive negative omega square root of a squared minus x squared. You all can have a look again all these mathematical function again, and finally we will get this equation. For maximum velocity of the particle at v max x equals to 0, by substitute x equals to 0 into this x square, you will get 0. So the v max equals to omega times amplitude, omega times amplitude. This is the velocity displacement graph. At maximum amplitude, v max equals to omega a. When the displacement x is positive negative a, the velocity is 0. This is the velocity. So when the positive negative for the displacement is a, the velocity is 0. For acceleration of the particle from v equals to omega a cos omega t, differentiate v into t to get the acceleration, which is equals to negative omega square a sine omega t. We know that x equals to a sine omega t. Finally, acceleration equals to negative omega square x. For the maximum acceleration, x equals to amplitude. So maximum acceleration equals to negative omega square a. Simple like a bubble without giving you any trouble. This is the graph of acceleration against displacement. Thank you for watching this video. Thanks a lot and thank you to the Lord.